So let's start with the syllabus, starting the first discussion with the books. The first book, it's almost a de facto standard to start your AI journey. It's now on the 4th edition, which is the one I'm recommending if you're buying new. If you can find the 3rd edition used, I understand that the cost of this book is quite significant. It didn't used to be so expensive, but now I think it's something like $200. It's a massive book of more than 1,100 pages or about that. And it's very well written and probably one of the best books in your library that you will use over and over again. So this book is a must get, either the 3rd edition or the 4th edition. And sometimes the 3rd edition is heavily discounted on various kind of outlets. The second book is, I don't have a paper copy of that, I have an electronic copy. It's available to you free of charge, as every NYU student has access to the library, and the library has offering an amazing service, which is the so-called O'Reilly Safari Books. This service, I will show you in a moment how to get there, but you can actually go to this website over here, this one over here, and it will ask you to log in with your credentials. So after you log in, you will be taken to this resource over here. The O'Reilly Learning Platform, which literally has thousands of books and all sorts of books, especially with respect to computer science, programming, hands-on books, that is most, but also some others. And we are looking at the book, which is called Hands-on Machine Learning with Scikit-learn, Keras, and TensorFlow. Now, apparently there is a 500 error over here, but that's the book that you will be accessing. I'm not sure why the error is happening, but it will be the book which is currently in the 3rd edition, and it's also a best-selling book right now in Amazon and other outlets. It is hard-coded to TensorFlow and Keras, and evidently we have the flexibility in the course to accommodate any framework, obviously PyTorch, and therefore there are other books such as the book Deep Learning with PyTorch, which is actually this one over here, and I'm not so sure if the font is large for you to be able to see, but definitely this is a book that is an alternative. And going back to the site, there is, however, my experience is that compared to the first one, then every other PyTorch book that I saw may not really cut it with respect to the depth of the material that is being presented. So even if you are in the PyTorch space and you're familiar with PyTorch, I do suggest accessing this book. In any case, they are free of charge for you. And the 3rd book is free of charge for everyone outside of the paywall of Safari, and it is sometimes used as an alternative to the 2nd book. And it's a book that I'm somewhat kind of familiar, but not. I'm not really using it extensively in terms of references as I teach, and it's accessible in this website, the d12.ai. This is a bit more practical oriented, but I'm very familiar with the deep learning book.org, which is written by Ian Goodfellow and other sort of significant personalities in deep learning community, and I do extensively kind of make reference to this book as well, as in the notes as well, also during lectures. A few words about exactly the stages that I referred to in another video, so that we start with kind of sequentially to how sensing information from various sensors, cameras, lidars, and so on, are kind of processed inside an agent. So the processing is actually happening on this first stage, which is called perception system. And the output of this kind of perception system is to produce a sequence of predictions, like a stream of predictions about, let's say, the location of the objects that are, let's say, in the environment of the agent, so that the agent has a kind of an understanding of what is really is facing and is be able to subsequent stages plan and act. So we have divided it effectively into 5 lectures. It's a fairly sizable set of material that will start you from the foundations of statistical learning theory. And by statistical learning theory, I'm mainly referring to the godfather of statistical learning theory, Vapnik. And we will start with the first principles of the regression problem and the classification problem and the core concept of maximum likelihood estimation. And then we will generalize these linear and generalized linear kind of methods into nonlinear methods, and we'll be implementing those with neural networks, aiming to finally get into the point where we're able to do at the very least object detection. And so we kind of limit the discussion to scene understanding to just detecting objects in our environment. And we are subsequently getting into the second part, which is reasoning. And in that kind of reasoning part, we start with where the perception system left and the various kind of object detectors kind of left it, where they just predict locations of the various objects surrounding us. However, they are of reflexive nature, and therefore every prediction could actually be noisy. And by noisy, I mean that in frame of a video sequence, the objects may appear, but maybe later disappear in the subsequent few frames because of some kind of random lighting fluctuation has happened in the system. So we need probabilistic reasoning over time, effectively tracking capabilities to be able to track the movements and the mobility of the various objects and to correct for instances such as occlusions. In fact, for occlusions, we actually may need to go into logical reasoning, which is a higher level reasoning, where the representation now becomes symbolic. And because of that symbolic representation, we actually can actually accommodate instances where we have occlusions for much longer periods of time. But in other domains as well, let's say cybersecurity, logical reasoning is also extensively used because we are able to represent and answer queries at a logical level. We're able to represent, let's say, a cloud deployment. AWS and other cloud providers are making heavy usage of logical reasoning in their cybersecurity systems, for example. So the kind of second part sort of finishes with this kind of presentation of the various hierarchical kind of view of reasoning. And the third part kind of starts to discuss, okay, fine, we have now a good idea about where we are and about the environment, and the question now becomes, what do we do about it? How do we use those? And of course, we use those in developing a plan. So planning is itself divided into 3 stages, 3 lectures. The first lecture kind of starts with planning without interaction, and in that kind of discussion we are starting from problems where we do not need much of a subsequent detailed information about the state of the environment. Maybe an atomic state, such as what is being used in planning, let's say a route from point A to point B, is enough, to more complicated approaches where we do need that kind of additional kind of sort of information that the object detectors kind of provide. So we will be limiting ourselves to, in that kind of first lecture, to without interacting with the environment. And we will be expanding then with the cornerstone of reinforcement learning, which is Markov decision processes. So Markov decision processes are being used extensively in problems that we do know the dynamics of the environment or all the probability distributions that we will need to actually solve the problem. So for example, take the way that we are reserving tickets in a ticket system like an airline ticketing system. We actually, the whole problem can be posed as an MDP problem, where we are trying to manage from the point of view of an airline our resources, the seats and fares, developing, if you like, fare classes. The same problem is posed as in problems like car rentals and a myriad of other problems. So reinforcement learning discussion starts with when we do know all the dynamics, and that is called Markov decision processes. And then it evolves into when we don't know the dynamics, and then in that case we are looking at algorithms that are able to learn those dynamics and help us act optimally. Now, the final part is reserved for a discussion on natural language processing. Ultimately, the course will evolve where natural language processing is going to be integrated into the rest of the discussion we had up to now. And but still, we need this kind of background, because in many other problems, the agent may take the form, let's say, of a bot. They may actually take the form of a chat system where you are trying to get to extract as much information out of a person who is interacting with it as possible and still satisfy the utility of the end user, the human in this case.